This is additional help for the 6G6Z3003 coursework. So this is help with question number 1. So here we have the tent map, which is given by t of x is 2x and 2 minus 2x for these range of values here. And we want to determine the fixed points of period 1. So to find the fixed points of period 1, we simply plot the line y equals 2x, which is given there. And this is the line 2 minus 2x when x is between 1/2 and 1. To find the fixed points of period 1, we solve 2x equals x, which gives us this point, and 2 minus 2x equals x, which is this point. And if you do the algebra on these, then we get these two fixed points of period 1. To find t of x, we simply use functions of functions. So we look at t, and wherever we have x, we replace it with t of x. So t, as a function of t of x, is twice t of x when t of x is between 0 and 1/2, and 2 minus 2 t of x when t of x is between 1/2 and 1. So now, on our original map, we need to indicate where t of x is between 0 and 1/2, which is on this range, and t of x is between 1/2 and 1, which is on this range. So if we take t of x between 0 and 1/2 first, then it's this lower range here, and we're going to look at these two branches, 1 and 2, of t of x. And if you draw a dotted line across, then we can see that for t of x between 0 and 1/2, we're going to have two ranges of x. So for t of x between 0 and 1/2, first of all we have x is between 0 and 1/4, so that's for branch 1, which I've indicated here. So we have twice, and t of x is 2x on this branch. So you have 2 times 2x, but now x lies between 0 and 1/4. And similarly, over on branch 2, so for branch 2, we have twice, but now the function t of x is now 2 minus 2x. That's this line here, is 2 minus 2x. So we have twice 2 minus 2x, and now the x range is x between 3/4 and 1, which is here. So that's branch 2. Now we need to look at this lower equation, 2 minus 2 t of x, when t of x is between 1/2 and 1. So now we're looking at t of x is between 1/2 and 1, so we're looking at branches 3 and 4. So for branch 3, we have twice minus 2, and t on this branch is 2x. So that's why that's 2 minus 2 times 2x. And for the other branch, for branch 4, this function is 2 minus 2x, so we have 2 minus 2 times t of x, in this case is 2 minus 2x, and that's for 1/2. X is between 1/2 and 3/4, so that's branch 4. So you can clearly see that these branches here correspond to these intervals. Now these intervals are in the incorrect order, so we have to put them in the correct order. So 1 is in the correct order, but you'll see that 4 should follow 1. So 4 follows 3. 3 here follows 1 because x goes between 1/4 and 1/2. So we have 2 minus 4x for x between 1/4 and 1/2. So I've put the new orders in there. This is our t of x, which we can easily plot because these are just straight line segments. And for period 2, we just want to know where do these line segments cross y equals x. And I've shown you that algebra here. These two fixed points are period 1, so we discount those two, and you end up with these two fixed points of period 2, which are here. So there are two fixed points of period 2. For period 3, we want t cubed, which is the same as t squared of t of x. So now we apply t squared of t of x. Here's our t squared. So wherever you have x, you replace it with t of x, which is given there. And I'll just do this is top equation for you. When t of x is between 0 and 1/4, then we're on this branch here. So t of x is between 0 and 1/4 corresponds to x between 0 and 1/8, and also x between 7/8 and 1. So this will be your branch 1, and this would be your branch 2. And these are the equations for this first line here. And then obviously you have to do the same thing for these three. Now for the other question in the coursework, you were asked to construct the Levy fractal. So what I've done is I've given you the stage 0 construction. For stage 1, you replace the line segment with a tri-square. So there's the tri-square on there, that's stage 1. And for stage 2, we plot the skeleton of stage 1 And then on here, you now have to plot tri-squares on each of these segments. So at each stage, you will see that one segment is replaced with two segments. So I will leave you to complete stage 2. And once you've completed stage 2, then use the skeleton of stage 2 to plot stage 3, etc. And that concludes the extra help for the coursework.